And we are live on YouTube with Professor Carmel Caruana from the University of Malta. My name is Luisa Volarte, and today I'm very happy to present our speaker. So, Professor Carmel is a pioneer in the teaching of medical physics and developed our profession in Malta from a day that it was not known as a medical physics career. He has a lot of expertise in talking about how medical physicists can promote our profession and how can we training and teach better. So today he will join us to share a future vision for medical physics profession. And I please ask you to say hi on the chat, say from where are you from, and if you have any questions, please write to us on the chat that we will be reading it to Professor Carmel during the presentation, okay? So nice to see you all. Please share this chat with your colleagues and friends. And Professor, you are free to talk. Thank you very much. And once again, good morning from Brazil to all.
Okay, thank you, Luisa, for that introduction. As Luisa said, the title of my presentation today is A Future Vision for the Medical Physics Profession. I will be talking a bit about my personal future vision for the medical physics profession, but mostly, since this is a presentation for young leaders, I would like to have a different kind of presentation, where I don't just tell you what my vision is, but I would like to compel you to think about what your vision will be. Let's see what I mean. You are young leaders, okay? Many of you are still young, but in a few years, the future of the profession will be in your hands. As my generation, we get older, which is a part of the nature of the world of things. We need to prepare the next generation of leaders, and that is essentially you. And for you to become leaders in a few years' time, you must start thinking about, what will I do when I become a leader? Because this is something that you don't decide overnight. You become a leader and then you say, okay, now let's see what I'm going to do. Okay? Role development and the development of the profession doesn't work like that. Okay? Role development and development of the profession needs thinking over a long period of time, so that you develop a proper vision of what the profession needs to be like in the future when you are leaders. Okay, let's move forward. So this is not going to be the usual type of presentation where I tell you what my ideas are. Okay, I will tell you that a bit towards the end. But I want to spend most of the presentation putting questions to you to force you to think about what you would like to do when you become leaders. It's a presentation designed to make you think, because leaders need to be good thinkers. As future leaders, you need to start thinking now where you would be taking the profession in the future, when you would be leading it. Notice each time I'm emphasizing, you have to start to think now for when you would be a leader and where you would push the profession in the future. In other words, you must develop your desired future vision. And that brings us to the title of the presentation, Vision for the Profession, so that you may prepare yourself for when your time as leader comes. Notice the word future vision. It means where would I want to push the profession forward when I'm leader? Because that vision is very important. It will be your guiding light when in everyday work. Okay. Um, for you, in everyday work, when you're at hospital, okay, you are doing many things, many problems arise all the time, okay, and you must have a vision that will keep you going in the right direction. Otherwise, the everyday problems that arise will take so much of your energy and so much of your thinking that you will lose any vision. So the development of a vision that will help you in everyday medical physics, but also help you to think all the time, not just what you are doing at the moment, but where you will want to push the profession in the future. This will be the thing that will be guiding you. This is called the guiding vision, okay, to guide you along the way. I will be stimulating your thinking with some very thought provoking questions. Question one, and it's question one because it's really the most important. Will I be a continuity leader or a transformative leader? Okay, these are two new words, probably for many of you. Will I be a continuity leader or a transformative leader? What does this mean? This is the most crucial question. That is, will the development of the profession under my future leadership be a slow, steady upward progression, but essentially leaving things as they are? Or will I go for the quantum jump, the paradigm shift, making big changes? Okay, this is a very important question. I have put another question down there to make you think. In this rapidly changing, economics driven world we live in, can we afford to leave things as they are or to change slowly? If we change slowly, will we be left behind by technology or even by economics? Transformative leadership is more satisfying ultimately, but also more risky. Okay? Remember, making quantum jumps is satisfying because often it makes all the difference. It produces real transformations and things, but it's also more risky. So one has to think carefully on a strategy on how to do the transformation. Question two. If I'm going to be a transformative leader, transform the profession into what exactly? So I have decided to be a transformative leader because I think that If I move slowly, if we change slowly, the profession will be, or my hospital group will be in trouble. So, what am I going to transform it? How am I going to transform the profession? What type of transformation would strengthen the profession and make it more relevant to society? Because this is ultimately what we want. What type of transformation will strengthen the profession, make it stronger, and make it more relevant to society? Because the stronger the profession is and the more relevant to society it is, the better the profession, the more appealing the profession, the more strong the profession. Which leads us back again to the title of this presentation. What is my desired future vision for the profession now, or in my hospital, or in my country? If we are going to transform, what are we going to transform it into exactly? And the transformation is towards your vision. So, again, what will be your desired vision? And this is the crucial, critical question that you need to ask yourself again and again and again. In what way should I change my profession to make it more relevant to society, to make it a stronger profession? And that's not a question that you answer by going to the bar and staying there for half an hour or an hour, okay, and you come out with a vision. It doesn't work that way. A vision is something that needs to be developed little by little. Huh? It needs quality thinking time. It needs quality thinking time. Question 3. Should I develop this vision on my own or with colleagues? This is a very important question. If I am going to develop the vision, should I bring my colleagues, if I'm in a hospital, for example, and I'm the leader of the medical physicists in the hospital, should I bring them together and we develop the vision in a collegial manner? Okay. I suggest that ideally, this is the best way of doing things. Ideally, it should be done collaboratively with colleagues. The reason why it is ideal, first of all, because even though you might be a good leader and you have good ideas, but none of us is a Superman. So other people will have also ideas. Sometimes your ideas might not be totally the best way of doing things. So bouncing your ideas of others will help you refine your ideas. Moreover, your colleagues can come out with other ideas which would maybe did not occur to you. But the most important reason why working collaboratively is the best, why developing the vision in a collaborative manner is the best, is that like this, the vision will be shared by all. Since everybody has uh, a part, taken part in developing the vision, then everybody will feel that the vision is also belongs to them. This will make them more motivated to work towards that vision. However, a point of warning now, it is not always possible because in this world we're all different. For some people, for example, transformative visions that bring about major changes is not on. Many people are afraid of transformative visions. They prefer the small changes or sometimes even no changes at all. Okay? So, this is one of the things that you have to decide about. And The way you decide is you have to ask yourself, what are my colleagues like? What type of character do they have? From the experience that I have with them, from discussions that I have had. Okay? Um, do they like fast transformations, or they prefer doing things calmly and slowly, or they prefer not to change? You're going to find all types of people in this world. And here, you have to take a decision. If your colleagues are ready to, are the type who would like transformative visions, then you can work with them. However, if you find that either all of your colleagues sometimes, or sometimes some of your colleagues are not on to work to change for transformation, then you have to keep them out of the process. It's not something that we like doing, but sometimes this type of people will actually be counterproductive and they will stall your vision development process. This is part of the world we live in. You can't, unfortunately, not everybody is the same. And in a way, it's better that not everybody is the same, because there are sometimes changes in the world which are better done in a small, sorry, in a slow, steady pace. Okay. But again, I will come to a comment that I made earlier, that we live in a fast changing world, both technologically and, very important, also economically. And the economics affects what we do. It's not just the technology that affects what we do, also the economy affects what we do. It's no use you wanting to do things if there's no money to do it, or if you're not capable of convincing the management of the hospital or the Ministry of Health to provide more money for that vision to happen. Or maybe we are living in times of austerity. That means there isn't a lot of money around. The amount of money to be shared within society is not so big, so there's a lot of competition for the money. So there you have to, again, check what type of vision you will have to go for in those circumstances, whilst never losing the sight of your bigger vision that you want the profession. All of these, I have passed through them myself. Many of these ideas that I'm putting here and questions that I'm putting to you are questions that I had to struggle with and grapple with in my own country, in Europe, because I was very much involved on a European scale in the European Federation of Organization for Medical Physics, EFOMP. So they are not new questions. They are questions that every leader who wants to bring change and move the profession forward will go through, and you will go through them also yourselves. You will have an advantage that at least you have somebody like me telling you, hey, you're not the only ones having these problems. We have also passed these problems ourselves, through these problems ourselves. In my generation, with most of these things, we had to do them on our own and realize what is happening on our own, which meant it took longer to do it. But I'm trying to put these questions to you so that in your case, you will face these questions as early as possible in your career. Because the earlier you face them in your career, the easier it will be later on, and the more you can achieve. And the more you can achieve. Question 4. How should I or we, if we're doing it as a group, formulate this vision? For example, many visions in this world, not just in medical physics, are done like this. We have an hour's meeting, Over a cup of coffee, okay, we discuss and we have strictly 1 hour, not more, and we agree on a vision, we write it up, and off we go. Unfortunately, that's a recipe for disaster, okay? Because a vision, as I said before, and I repeat, is something that needs to be developed over months, sometimes over years. As we gain more experience, as we see more what other people are doing, okay? So, definitely not. It cannot be done in an hour's meeting or a 2 hours meeting over a cup of coffee. We need a research based strategic vision. We need a research based strategic plan on how to achieve that vision, like we do, and we as medical physicists and physicists in general, or engineers in general, we're very good in, in our research, in our science, or in our healthcare. Okay. We must also be very good in research for creating a vision, a strategic vision that will push the profession forward, and a research based strategic plan on how to achieve that vision. Because if it's not research based, if it's not carefully thought out, it will fail. It will fail. You aim for 100% and you will achieve 30% only. Sometimes you can even regress. If you don't have a strategic plan to do things in a proper way, sometimes instead of moving forward, you move backwards. And the research method to use is something called SWOT analysis. Now, SWOT analysis, many of you probably have heard about it, if you have heard my talks on leadership before. SWOT stands for strengths, weaknesses, opportunities, and threats, which means what are the strengths of the medical physics profession, or what are the strengths of my medical physics group in my hospital. What are the weaknesses of the medical physics profession or the medical physics group in my hospital? Everybody likes looking at their strengths. We don't like looking for our weaknesses, okay? But not realizing that you have certain weaknesses is one of the biggest mistakes you can make. Because if you have weaknesses and you either don't realize that you have them, or you realize but you sweep them under the carpet, you don't acknowledge them and face them so that you remove those weaknesses, then you'll be in trouble because those weaknesses will bring you down. So those weaknesses have to be either allowed for or eliminated. Opportunities. What opportunities exist that will help me, can help me if I take them, if the profession takes them, to help me achieve that vision? I must look for the opportunities around me. Again, what threats exist to the profession or to my group at the hospital that will not only perhaps um, not let me achieve my vision, but even destroy it or destroy my group? Okay. Threats are also very important. They need to be analyzed, they need to be attacked and destroyed. Otherwise, those threats will destroy me. Okay? This is strategic thinking, guys. Remember, as physicists, they don't bring us up too much. They don't teach us much on this SWOT analysis in our education. Okay? They teach us a lot of physics, mathematics, computing, but not these things. But these things are important, and they're important in today's world. As many of you might have heard me say, and I keep on insisting, that in today's world, being a good scientist is not enough for a profession to move forward. You also need to be a strategic thinker. You will find a compendium of ideas for SWOTs for the medical physics profession to help you in this book. When I started doing leadership courses specifically for medical physicists, the first thing I realized, first of all, there were no courses available, nowhere in the world. Secondly, we didn't have a single book about leadership specifically for medical physicists. So, as I gained experience and as I started growing older, and I realized that it's important that I do whatever is necessary to help the future profession, the future leaders of the profession, like yourselves. I said the first thing to do is to write a book. In this book, I have taken the experience of not just myself, but many other medical physicists, medical physics leaders of my generation that I have spoken to, sometimes even of previous generations, those who were before me, and even sometimes from your generation, because whenever I go to conferences, I speak to everybody, because this is the way for you to grow as a leader. You must speak and talk to others so that you gain from the experiences of others. This book, you have a whole chapter on strengths of the profession, a whole chapter on the weaknesses of the profession, a whole chapter on the opportunities, and a whole chapter on the threats. You have a whole chapter on the differences between mission and vision. They are not the same thing. Be careful. Mission and vision are not the same thing. There's a whole chapter on how to develop a vision. There's a whole chapter on SWOT analysis. Okay, so please go for that book. If you, by the way, if you try to buy that book, put in Caruana, I think. But if you write to me, I can give you a code so that you get 50% discount, something like that. Write to my email address, which you'll find at the end of this presentation and also at the beginning, and I will send you what the code is. I'm sorry, I forgot to write it here. And I negotiated that code specifically for you so that it will be easier for you to buy the book. Question 5. Should I expand further the role of medical physicists? The traditional role of the medical physicist was ionizing radiation. Full stop. Ionizing radiation in medical imaging, um, nuclear medicine, and radiation oncology or radiotherapy. Okay? And it still is in many countries in this world. That's where the role starts and ends. The IAEA is mostly dedicated to that. Okay. But the question I'm asking you to reflect upon here is this role enough? We have moved in the last few years, we have moved to MRI, we have moved also a bit to ultrasound, but even this, is this enough? Okay. Is this enough to turn our profession into a bigger profession, into a more interesting profession? Is this enough? And I'll be speaking a bit about this later on, but just to give you a hint that in Europe we are moving. I have been talking about to my European friends about this for more than 10 years, and finally, at last, it has been agreed upon that medical physicists should move to all medical devices in the hospital, not those just related to ionizing radiation, okay, and all physical agents used in the hospital, not just X-rays or radioactive materials, but and strong magnetic fields and MRI and ultrasound, but even lasers and use of ultrasound for therapeutic purposes. Okay, like for example, is used in physiotherapy or shortwave diathermy. View this is uh, the way I explained it. The the number of medical devices in hospital, if it's this amount, those in ionizing radiation are only this amount. So what is happening in the rest? Are the things being checked? Quality control? Is there somebody helping the healthcare professions in nursing, etc., to use the medical devices properly? I still remember the incident, even of something simple like thermometers, electronic thermometers. They were checked in a hospital. 70% of the thermometers were wrongly calibrated, were giving the wrong temperature. 70% of the thermometers in the hospital. Okay. What is happening to blood pressure measurement gauges? What is happening to glucose meters in diabetes? Are these being calibrated? Okay. So the number of medical devices in hospital is large. We need to move to these medical devices also. This will have a very important impact on us because it will mean that more professions in the hospital will get to know about us, not just those working with ionizing radiation. Yes, in a rapidly changing technology and economics driven world, a profession that does not expand its role will eventually decline. We will eventually decline. What will happen if, for example, um, ionizing radiation, they find, for example, a cure, a biochemical cure or a biological cure for cancer, which means that radiotherapy or part of radiotherapy will fall out. What happens? If we put all our eggs in one basket or a few baskets, okay, there won't be many other medical devices that we can work on. Okay, so it's important that a role is expanded as much as possible so that it will always be important for society. The smaller you make your role, the easier it is to disappear. The wider it is, the stronger it becomes. How to expand the role? Ask yourself questions. Which areas of healthcare are not being addressed and which medical physicists are ideally suited for? Remember, we as medical physicists, we have very particular talents, guys. We are very strong in problem solving skills. We have a lot of analytical skills, mathematical skills, okay, that will be useful in hospitals. And we are only limiting them to ionizing radiation in many countries. Are there other specialties which medical physicists in other countries are involved in and which you are not? Let me give you some examples of these. For example, in Finland, you have medical physicists in neurophysiology. In Austria and Germany, in audiology. In England, physiological measurement. In the Netherlands, something called the general medical physicist, who works in the hospital as a whole, not just in medical imaging department or radiotherapy or nuclear medicine, but the hospital as a whole, to see many other to check many other medical devices, to advise the management as a whole what devices to buy and how to and what specifications should they have, but not just ionizing radiation, but throughout the hospital. In fact, this year I gave one of my students, because we don't have the general medical physicist in Malta, I gave as a project to go to the Netherlands and do a research study on what exactly is the role of the general medical physicist there. And she did interviews and she did observation of the general medical physicists in the different hospitals. She checked what type of publications they do. Okay. She had a questionnaire, and so that I will introduce this in my own country. This year, EFOMP, after I have been saying for quite some time, we have set up a special interest group on physiological measurement. And hopefully next year we'll be um, uh, pub, pub, publishing this policy statement on the role of the medical physicist in physiological measurement, which could be an enormous role, because physiological measurement, you find it in everything from cardiac to neuro to muscle measurements. Okay, you find it everywhere. You find it during surgery. Okay, this year, in fact, in my own bachelor's and master's, we are introducing physiological measurement because I want to push this in my country. So notice, this is the way to develop a future vision for your country, guys. See what others are doing. Question 6. How can I make medical physics a mainstream healthcare profession? This is a very important question. As you know, as a medical physicist, we're a very small profession. We're a very small department in a hospital. Often, most healthcare professions don't even know that we exist. Okay? Certainly, most patients or most the general public don't know that we exist. How are we going to solve this and make ourselves a mainstream profession, a profession like the others, well known throughout society? By mainstream, I mean easily recognized as a healthcare profession. How can we make ourselves easily recognized as a healthcare profession? Some time ago, my European friends, colleagues, they set up a syllabus for medical physics. And one of the things that they put was that there will be 10 ECTS, 10 credits so, for anatomy, physiology, pathology, etc. And the question that my reaction immediately was, how can you expect us to be recognized as a healthcare profession when we only have 10 ECTS of anatomy, physiology, and pathology? When, if you go to the other professions, physiotherapy, radiography, nurses, they have 30 ECTS in the first year of their bachelor's. This needs to be addressed. Otherwise, you will never be recognized as a healthcare profession. They will always see us, there are those technical people there that are enclosed in a small office somewhere. Okay. They don't even know the anatomy. How can they are calling themselves a healthcare profession? And this is something that needs to be a weakness of our profession that needs to be addressed. Not we ignore it. Huh? How is it we are going to make our profession well known by the other healthcare professions and the health authorities and the general public? There's another question that needs to be addressed and which is continuously on my mind. I have solved it quite well with the other healthcare professions, or practically solved, even with the health authorities. The general public, I'm still far away from that in my country, but I want to solve that if possible before I retire. Okay. Question 7. How to make the medical physics profession a bigger, more numerous profession? We are too small. When you are small, even though you're a good profession and very well learned and super, we are super as a profession. We really know our stuff well. We're highly intelligent, very good at problem solving, very good at analytical thinking, but we're small in number. If you're small in number, you will always be politically weak. So how can we make our profession bigger and more numerous? And this is also a question that needs to be addressed. Question 8. Should we increase our direct clinical involvement with the patient? At the moment, traditionally, we're always technical people, okay? More involved with the technology than the patient. Is this correct? How do we expect that the patients get to know about us and society at large gets to know about us if we don't involve ourselves with patients or even with society at large? How? So the answer to the question should be a definite yes. We're already doing it in my country a bit nuclear medicine, especially nuclear medicine therapy, but we need also to increase that. Question 9. What makes a medical physicist different from a biomedical engineer? Okay, traditionally we confuse these two things. Sometimes we don't know one from the other. We always say that they overlap, but we don't know exactly what this overlap is. Okay, but there's a distinction between medical physicist and the biomedical engineer, and the distinction essentially is that the biomedical engineer always looking at ways of developing new medical devices. So the biomedical engineer tends to work mostly and look towards the manufacturer of the devices. And it's an important, because we need to develop new devices. But the medical physicist should look the other way. Medical physicists should be centered on the patient. After the biomedical engineers develop the devices and they move to hospital, okay, the medical physicist takes over to make sure that we buy the right devices, make sure that they are quality controlled. We make sure, very important, that they are used in an effective way and a safe way. Okay, we may try to involve ourselves with patients, explaining to patients what the devices are, explaining to the healthcare professions exactly what the devices do. We are still in a stage where many healthcare professions are using medical devices without them knowing exactly what they are doing. And this is not just in my country, it's a worldwide phenomenon. Okay? So there's a lot of things that we can do there in the hospital. And this is the distinction between a biomedical engineer and a medical physicist. By the way, a medical physicist can be an engineer, yeah, can start out as an engineer. But if he has, these are two professions here, not where you come from. Okay, you can have your background in physics, and your work is the development on the devices. So you're really more a biomedical engineer, or you can be an engineer, but you move into hospital as a medical physicist to work more on the devices whilst in the hospital. Okay, so there in my masters I have even engineers, but I always tell them medical physicist is not where you come from, whether you come from a physicist or from an engineering. Medical physicist is a profession, and the profession dedicated to make sure that the devices that we have in hospital are used effectively and safely. Okay, that is a profession, whether you come in from physics or engineering. That's a distinct profession. But if you want to, even when I go and talk to students pre-university to tell them about the profession, and somebody tells me I would like to develop new technologies, I tell them, then please don't come to be a medical physicist. Go towards biomedical engineering, because there you need to learn a lot of electronics, etc. Okay, and you don't need to learn a lot of anatomy. You need to learn more electronics than anatomy. But a medical physicist, he's with patients. We need to learn more anatomy and physiology. Okay, so they are two different things. Question 10. Sorry, this should be question 10. Very important. How to make medical physics independent of what happens in physics or engineering. What do I mean by this? Often not often, traditionally, medical physicists usually they start from a bachelor's in physics or engineering, and then they come and do a master's in medical physics. But we have had a major crisis in the last 10 years in many countries because there aren't enough physics graduates, there are enough engineering graduates. So we didn't have enough to have medical physicists of them to come in our masters in medical physics. This is a very very um, dangerous situation in the sense our profession depends on what happens in physics or engineering. It cannot go on like that. And I had to solve it myself because we were in my country, we were in a crisis situation. Transformative visions require changes in the perspectives and attitudes of the professionals. A new kind of professional. Notice what I've spoken about. We need a new kind of professional. Okay. And I considered in my time that a vision of a new kind of medical physicist who is more patient oriented, more anatomy and physiology in there, whilst of course keeping strong physics and mathematics and computing skills. But we need more to move also to biomedical sciences. Otherwise, we cannot be considered as a healthcare profession and we cannot contribute fully to healthcare. Now, this is very important. Look, therefore, every transformative vision requires changes in the structure and content of the education and training system. To produce a new type of professional with a new vision for the future, we need changes in the structure and and content of the education and training system. Let's look at the present structure of our education and training system in many countries. First degree in physics or engineering, 1 year master's in medical physics, 2 to 3 years clinical training in all specialties of medical physics. This is the most common, still the most common. If you look at it and consider the questions that I spoke about earlier, you'll look at it and you'll see that for a future transformative vision, it's a disaster. First of all, first degree in physics or engineering. That is already making us dependent on what happens in physics or engineering. We still need to have a very strong background in physics, so physics still needs to be there, okay? Or the physics part of engineering still needs to be there, but we cannot depend on just physics, getting students from physics or engineering, because if they fall, if physics or engineering falls, we fall with them. A profession cannot be dependent upon another. Second, and in this first degree, we practically do, obviously, we do zero anatomy, physiology, etc. We have no hospital experience. Then we have 1 year masters in medical physics. And this 1 year masters in medical physics, sometimes it's a 2 year master, but mostly 1 year masters these days, because 2 year masters, nobody wants to go for 2 year masters anymore in many countries. Even I had to move my masters in medical physics from 2 years to one because students don't want to spend 2 years on a master's anymore. So we have a 1 year master's. Can somebody explain to me how in a 1 year master we can do all the medical physics required, we can do all the radiation protection required, we can do all the imaging modalities, radiotherapy, nuclear medicine, plus do a lot of anatomy, physiology, and pathology, some healthcare management, some leadership skills? Just not possible. And then we do 2 years, sometimes 3 years, clinical training in all specialties of medical physics, which means obviously we try to do all of medical imaging, ionizing and non-ionizing, radiotherapy, all the type of radiotherapies we have, all brachytherapies also, nuclear medicine, both diagnostic and therapeutic, which means obviously we try to do everything and we're good, very good in nothing, because that's what happens when you try to do all these things in such a short time. And these things have expanded today so much that it's simply impossible to do all the specialities. So notice the way it is at the moment, it is still practically traditional medical physics. Still, practically the structure is still for when we did just ionizing radiation. We haven't changed. Huh? I have changed it in my country, and I'm going to show you how I have what I have done in my country. So the basic problems with the structure depends too much on what happens in physics or engineering, extremely low level of biomedical science. How can one call oneself a healthcare professional with just a few ECTS of anatomy, physiology, and pathology? Our students never meet the other healthcare professions or enter a hospital except after the masters. When they go into hospital, then after the masters, they are not prepared for the hospital environment. This needs to change. This is what I've done in my country, a paradigm shift I've done. First of all, a bachelor's not in physics, but in physics, medical physics, and radiation protection. This makes sure we have strong physics, mathematics, computing, but we're already doing medical physics and radiation protection because a 1 year master's is not enough to do them all. And we're also doing a lot of anatomy, physiology, and pathology. 2 years training, but in one specialty only. So that at the end of the 2 years training, we're really good in that. And when we go to into the hospital, we're capable of making changes from day one, not take another 2 years to learn what to do. This is the structure of my BSc. Look at this structure. It is a 4 year BSc. It has 5 strands: physics, mathematics, statistics, programming, physics practicals. Okay. My students, then another strand in anatomy, physiology, pathology, healthcare ethics, and management. Another strand in medical physics and radiation protection, where we have all medical devices and all physical agents. Hospital medical physics and radiation protection practicals, they have nothing in the first year, but 112 hours in the second, third, and fourth year, and research. The physics lectures, etc., and practicals, they join with the normal physics classes, because we need to have strong physics and mathematics, statistics skills. Anatomy, this is important. Anatomy, physiology, pathology, they join the classes of radiographers, physiotherapists, etc. So that they, first of all the other healthcare professions know about us, know that we exist automatically. Moreover, the students get to know how to work with other healthcare professions. Medical physics and radiation protection, all medical devices, and all physical agents to expand the role, not just ionizing radiation. Clinical practicals in hospital, so that the students get to know the hospital milieu as early as possible in their career. Moreover, the other healthcare professions get to know us, those that are already working in hospital. And finally, research. The asterisks are the number. I mean, for example, physics starts very strong in one and then it decreases slowly. Again, anatomy, very strong in year one, decreases slowly. On purpose, it's like that to show that we have a foot both in the physics and also the biomedical. Then this obviously increases. Medical physics increases. This is throughout. We don't do any in the first year because they would know nothing in the first year, so it's silly. Then and research. If you want to look at some the details of my bachelor's and my master's, in the master's we now have time to do many other things, even machine learning and physiological measurement. And thank you for your attention. Hello, Louisa.
Hello.
I've stopped sharing.
Yes.
Okay.
So thank you so much for your talk. It was very intriguing. I already have some answers and some questions.
Okay. Well,
So,
let's go with the questions.
okay. So, do you think this is more this the situation of medical physicists as work health professional, it's more developed in developed countries, or do you think we
Okay.
we are a little bit near to develop our profession in countries that are bigger. What do you think? Do you think it's more difficult to develop our profession in small countries?
Well, I actually it's not like that. You find that. Do you know what is the most important thing? The individual leaders that you have in the country. So you can
Okay.
have countries which are very developed and which move towards this vision, and others which are not developed and move towards that vision. And then you have others which don't move towards this vision, which are very well developed, but they have a lot of equipment, but they have not moved. They are still technical only. They are still not seen as healthcare profession. It all depends, believe it or not, on the individual leaders. It's the leaders that make the difference. And that's why I am, in the past 10 years, I've been working a lot on this leadership, because it's the individual people that make the difference. Okay, so even if the profession doesn't change in the country as a whole, but you change it in your own hospital. Okay, are you following? You change it in your own hospital, because many changes start from a hospital. And then then you go for a conference and you talk about it, and other people say, oh, what a good idea, can we come to your hospital to see what you're doing? This is the way the world changes. The world doesn't change. We have a meeting and suddenly last year we were like this and now we're going to change. The world doesn't change like that. The world changes when there are individuals who realize that a transformation needs to be done. Okay, and they work for it. Remember, and often you have even opposition at the beginning. You have opposition because many people
Yeah.
don't like change. And let's not look just at medical physics, even physics itself. Look at all the opposition that Einstein had, for example, or that quantum theory had at the beginning. Okay, the early quantum physicists and the relativity, Einstein was seen as a cranky old. We don't know where is this guy going to. Okay, in fact, even
Yeah.
Einstein was never given a Nobel Prize for relativity. Do you know that he was never given a Nobel Prize because other physicists didn't accept it. Okay,
Okay. And it leads me to another question. So, as an individual leader, how can you cope with these different ideas, and when you have a colleague that it's also a leader, that it's in a position to bring change but doesn't agree, so how do you cope with it as being
okay. This
a,
will this will
a
depend on
young leader?
this will be depend on the country that you're in.
Yeah, sure, sure.
First, I will tell you why it depends on the country you're in. It's whether you can move from a hospital to another. This is very crucial. For example, in Malta, I had the most difficult situation because we're a small island, only one hospital, full stop. One big hospital, but only one. Okay? So I had to bring about change in a hospital which didn't want change, including the medical physicists themselves at the time. And I had no other hospital or no other hospitals to work with because I'm a university person, not a hospital. So I had to bring the change slowly. I had to find people who were ready to bring about the change. And believe it or not, in my case, I had to work with people. I was lucky with people from the Ministry of Health, more from the medical physicists. Okay.
Okay.
And so then you find other countries where the medical physicists want to change, but there's opposition from the Ministry of Health. Okay. So there you have to start looking at the Ministry of Health and get to know the people at the ministry to check who in the Ministry of Health would be receptive to your ideas. Okay, ready to receive your ideas. And again, don't think it will change overnight. I remember at the beginning, I used to go to the Ministry of Health with a small PowerPoint telling them what medical physics is. It's as if you, because for many of these people, medical physics means Newton's laws of motion. Okay, many of these people in the ministries, they don't know what. Many of them had never heard what medical physics is, so for them it's new. What are you telling me? Newton's laws of motion in the hospital, sort of. Okay, so and then you start making headway, and then suddenly you don't hear anything from them anymore, and you go and find that the person has been changed, because politicians are like that. They change people,
Yes.
okay, or the government changes sometimes changes so you start again. Okay, so don't think that it's something that you'll do overnight. It's something that, but little by little, more and more people get to know about it. Okay, and at a certain point, it's the critical point where comes. Okay, that's how it happened to me. But I'm sure that every country and every region in big countries, because a big country like Brazil, in your case, will have different regions with different ideas. And okay, so you have to start working within your own region, often, or within your own hospital, and will be different. And the history of each one of us, the history of each leader, like my history and Kwan's, Professor Kwan's history, is different. Okay, so don't think there's only one solution. It just doesn't work like that. But what is important is to think about what I've said today, and think, and finally you will find a strategy. Okay, you'll find
Yeah,
this.
I really like the idea of the slot, because in this way we can organize the ideas and see what we can do in all possible scenarios. So it's a nice way to start,
Uh,
right?
it's the
And
way to, as you said, it's
another
the way. Yes.
yes, another thing that I would like to talk about is the idea that medical physicists are really far away from everybody. So I really don't know if this is one of your questions. If we need to emphasize our presence with patients so patients are aware that we exist, and we should also emphasize our presence in the hospitals. And it's hard, but I think it's a good start if we start participating in things that are more from healthcare and have uh, a multidisciplinary environment that people see us and listening to us. So I agree when you say we need to talk. So we need to talk, and we need to talk as medical physicists. We need to
Uh,
say, hi, my name is Luisa, and I am a medical physicist, and I can do this, that, and I can help you with this, and that,
exactly.
because we
You have to
exist and we solve
walk out of.
problems.
You have to move out of the office. This is what I tell medical physicians: move out of
Yes,
the office.
exactly. I
Okay,
agree.
but even
I couldn't agree more.
even simple things, like, for example, suppose you're moving simple things. I tell them, suppose you're moving a phantom, okay, from one part of the hospital to another. Often you have a trolley and you're moving it. Okay, write medical physics department or medical physics on the trolley. It passes through many parts of the hospital. Okay, and people, what the hell is that? Write medical physics on it. It's a moving advert. It's a moving advert. Okay,
Yeah.
if, for example, suppose some accident has happened in the country, okay, involving radiation, the medical physics profession should put out a press release, okay, for the general public, giving advice to the general public. Okay, this is how to make, for example, in my case, one of the best ways was when I started a course for nurses, because let's put it this way, nurses are the biggest profession. If nurses get to know about you, everybody knows about you.
Yeah, that's true. Yeah.
I mean, so, but this is the way uh, we need to also learn how to market our profession. This is
Yes.
marketing ultimately.
Yes.
We need to
Yes.
be good at marketing.
And we are here to solve problems, right? Because we are basic physics. Our basic ground is physics. So physics solve problems, and people need someone to solve their problems. and we are here to
Exactly.
help. I think this is one way, one strategy to show ourselves and see that
Let
we
people,
can be helpful to
yeah,
everybody,
let
right?
people get to know about us. For
Yes.
example, even simple things like your email, for example, at the bottom, right, put a short note what medical physicist does, not just your name and the medical physicist. And
Oh,
in
nice idea.
my email address, I have short. It was used to be longer before. Now it's a shorter one. But before, in the beginning of my career, I used to have a very long end of email thing, even with links to our most important journals in the world,
Oh, nice. Good
so that
idea.
when
It's a
people
good advice.
receive, and even at the Ministry of Health, they
Yeah.
go and click on some, well, medical, Journal of Medical Physics. It's This is the way to do it.
Yes.
I
So
mean, just
we have a
read a book about marketing, not about physics.
true.
This a book about marketing. An
Yeah, true, true.
idiot's guide to marketing. Idiot's guide to marketing. Some book like that.
Okay, so we have a couple of questions here. Can I read it to you?
Please go ahead.
So we have a question. The question is, transformative leadership can be very subjective. What are the guiding principles will you think be important at this stage?
Okay. Well, transformative leadership or any type of leadership remains subjective if you don't base it on research.
Oh,
If you
okay.
base it on research, then it's not subjective anymore. It becomes objective. Okay. And please, if you have some time, go to the book that I've told you about. But ultimately, you must base it on research, not on personal opinion. Okay. You must develop your vision based on research. What technologies are moving? What technologies will be important in 5 years' time? For example, now we're talking a lot about AI. AI started 3 4 years ago. As
Yes,
soon as it started 3 years ago, I put it in my master's program, machine AI and machine learning. Full stop. So it's a research kind of thing. Hey, where is the world going to?
yes,
Okay,
yes.
that must be based on research. What
Okay.
medical devices are we introducing in the hospital?
Yeah,
What?
that's a really nice idea because our last chat was about AI in
AI.
medical physicists. Yes, yes, it's good. It was really good. And another question that maybe I can give my personal opinion because of my background. So the question is, since you have bachelor's in medical physics, does master's still important here to be medical physicist? And how do you see the differences between bachelor's and master's? So here I think it's something that can change from country to country. We see Europe is a little bit closer to America in this idea, the bachelor's and master's. In Brazil, it's a little bit different. We to be a specialist in radiation oncology, or I don't know, maybe diagnostics, we don't need exactly a master's. Master's is something that you can achieve afterwards. So we need 2 years training here. So I think this is some differences that we can see the country to country in different locations. But of course, we have a guidance from international agency that gives some guidance how can we do our education, right? So I don't know what if you could comment on that as well.
Yeah, my view is that it's very difficult to prepare yourself just in the 3 years of a bachelor. Remember, there's a lot of content to do. Um, so I have tried this. I was going to try it, but when I started looking at the amount of content that needs to be done, I said it's just not possible. Uh, a full a full preparation for a medical physicist needs 5 years. There'd be either 3 years bachelor's and 2-year masters. In my case, I've chosen a 4-year bachelor's and a 1-year master for many reasons. For example, practical reasons. In Malta, students don't pay for their bachelor's, but then they have to pay for their master's tuition fee.
Oh, okay.
Okay, so it's better to do 4 years, and they get 4 years free, and then 1 year only they have to pay. Now I have got it
Yeah.
free for them also because we need medical physicists also.
Oh, yes.
Um, and the bachelors they are paid the stipend, students, and the masters they are not paid the stipend. So
Mhm.
it's better to do it like that. But to go back to your question, I think less than 5 years you can't become a real strong physicist. Because there's a lot to do. Even physics, maths, and computing on its own, it's already a lot. Can you
Yes.
imagine? We have to put anatomy, physiology, and pathology, and then do the medical physics, the first specialties,
Yeah.
especially
In
when the
Brazil, we
role
have
is
like
increasing.
4 or 5 years of bachelor, and then we
Oh,
do 2 years of training.
okay, so it's a 5-year bachelor.
Yes.
Oh, it's
Yeah.
actually you're actually the same as us then,
Yeah.
because
It's similar.
it's the same.
Yeah.
In fact, in Europe, there are people who don't do a bachelor. It's immediately a 5-year program, but they end up
Oh,
with a master's at the end. They give them a master's. Okay, so it depends from one country to another. I think the most important thing is that you have a 5-year program. It has to
okay.
be 5 years because less than because ultimately we have the same amount of material to study as doctors do. Okay, sometimes even worse because the physics and maths is more difficult than the anatomy and physiology. So
Yeah.
we have a lot to do. Okay, so
So, yeah,
less
yeah.
than 5 years is difficult, I think.
I agree. So we have already reached 1 hour and 10 minutes of chat. We
Okay,
have one more question and then
okay,
we are done
doesn't
here today. So the question is, what do you think about the inclusion of data analysis and AI type of course in a more practical programming intensive manner? So we already speak a little bit about it. Maybe the difference here is that we are talking about something more practical.
yes, I think this has to be, as I said, in the case of my master's, we have 10 ECTS, that is 50 hours of
Yeah.
lectures in AI and machine learning. But I think the way AI and machine learning is increasing, I think AI and machine learning will become part of everyday hospital work. Now it's still considered as as a special situation, but I think there will be a time when we have to start doing some AI even from the first year. You know, some more AI in the second year. Because AI is like mathematics. It's a tool that you use like
Yes, yes,
computing. It's a tool that you use. So the earlier you start using it, the better you become. Not spend 4 years not doing any AI and find in the final year you do AI. Okay, because
yes.
now we're going to start meeting it in the hospital from the first year. In the second year, we're going to start meeting in the hospital. So we need to
Yes,
start doing some what like we do mathematics now. We do from the beginning, even
yes.
and the AI will be like that in a few years' time. A few years' time.
Nice. So I would like to thank you, Professor, for the opportunity and for the talk. I think it's the second or third talk you give to us
Yes, the
for
third
our
one.
to our
The third
the third. Yes. So thank you once again, and I thank everybody that is here today that join us online. Please stay tuned. We will have another talk with Professor Simone from Brazil next month. So we will be advertising it soon. Stay tuned in our social media. And if you want, you can put your email here on the comments that we can send you a personal invitation. Okay. So thank you very much, Professor, and see you soon next time.
Cheers. Ciao. Bye.
Bye bye.